So I'm going to trust you have one somewhere, and you're going to look real hard, okay? Okay, good.
I have one too, but I did not bring it.
Yeah, mine's in my locker.
Okay.
What?
Please, don't make me feel like I'm on the other end of the building. We'll move forward and we'll bring them next time, right?
Yes.
Good. It's really something. I go up there for one class a day now. Now I know how you guys felt last year having to go up there for one class a day. It's like trying to walk through a fan.
It's pretty fun, huh?
It's a different world. All right, so draw yourself a little circle, maybe like the size of a quarter or a 50-cent piece.
Don't have a quarter.
Well, you know about how big it is. You can do that. Not with a quarter. Yeah, go round and round and round and round with your pencil.
Oh,
We
with
won't, we won't do that one.
the compass, huh? Those circles.
Yeah. And then set down your pencil, or whatever you're drawing with. Stand up. Make sure you're a fathom distance from everyone. That's a fathom, right?
Oh, shit.
Or one caribou length or something like
I'm
that.
at 6'1" wingspan.
Are you 6? Good. Okay, so I'll make sure you're at least your own wingspan away. And then here's what I want you to do. I want you to be able to pick something out that's more or less straight ahead and try to kind of sort of focus on it. At least use it as a place. You guys gonna play or not? We're not gonna make you say the Pledge of Allegiance or something. Just wanna
All right, I'll
stand
play.
up.
It's a game?
No, it's not a game. No, nothing's a game. It's
You
serious
said
stuff.
play.
This is serious
It's
stuff.
geometry. So I want you to kind of zero in on an object, you know, something that's small, that's going to keep your eyes going in that direction. You don't have to necessarily focus on it, but something that keeps your eyes going in that direction so your eyes aren't waving back and forth. I want you to put your hands back so that you can't see your hands. Look at that object. Bring them around. And then when you can see both of your hands, stop and look at where they are. And draw that angle as though you are the center of this circle.
Wow.
Pretty obtuse.
How do we draw it?
Pretty obtuse.
Is yours obtuse or is it acute?
Definitely obtuse.
Obtuse, that's good. If you
Did
were
I
a
make
moose,
this
it would be really obtuse. If you were a bear, it would be closer to acute, but probably not too acute. So yeah, so you just want to be out here. And bring it in, and you know, you'll know that they're there. You don't want to go turning your head and looking or moving your eyes. Just,
Oh,
and then, just for the fun of it, figure out where your nose was, put a dashed line there. And measure those angles. Measure them and find out what the sum of the two angles are. And we want to know what it is from,
well, it's about 90 degrees.
we want to know what it is from this point around total. You got a protractor? Really? Oh, I'll give you one. You might have to estimate it. If you have to estimate it, estimate it. Is anybody's more than 180 degrees? Probably not. See, we have our eyes mounted on the front of our head, which is more like a predator than a prey. Think about a moose. A moose can see almost behind itself, but a bear can't. Bear mostly looks forward. A salmon gets to look way back, but a sea lion gets to look up front. Because the eye placement of a predator allows for using the angle between their eyes and the object that they're looking at to determine distance. Whereas a moose doesn't care about distance. A moose just wants to know if something's coming that's going to hurt it. and then it can turn around and deal with it. But a bear wants to know how far away that object is to know if it's worth chasing or not. So what kind of measures do you guys get?
I like 155.
155? 170? 65? Something a little less than 180? If you estimated it, was it a little bit less than 180?
Yeah.
Okay, so could you do this then? Could you go and say with a little arc like this, what the angle measure is? So if mine is 165, I'm gonna write that right by that little arc that I drew that connects the two segments that create the angle. Is it okay if I write in red, or is that gonna be bad?
It's good.
It's okay? Okay, so here's what I'm gonna do. I'm gonna say that the center is point A, so we're gonna call that circle A. And then I'm gonna label one end point, that's an end point of this arc. Point B, and the other one's C, that's also an end point. And I'm gonna do a few things. We're gonna say that if I wanted to name that red arc, if I wanted to call it an arc, in words I would call this arc BC. And we would write it like this, kind of like the way you get started when you do a segment, a line, or a ray. You name the two endpoints, but then we put an arc because it's an arc. And sort of like angles, we use a lowercase m in front of them and we say what the measure of the angle is. If we wanted to say what the measure of that arc is, we would do the same thing and put a lowercase m. And then we could say the measure of arc BC is whatever you thought it was. And the measure of the arc coincides with the angle measure of the segments that reach from the center of that complete circle that the arc sits on. And it connects the center of the circle to each of the endpoints. And this arc here is less than 180 degrees. So we call it a minor arc. A minor arc is less than 180 degrees. And then of course there's a major arc, which is more than 180 degrees. So arc BC is a minor arc. And if I went here and I put a point D out here, now what we can do is we can name the other arc, the one that stretches from B through D to C. We can name it kind of like we used to name angles when we would go through the vertex of an angle, and we would use 3 letters. So we can say that BDC, arc BDC, is a major arc. Oops, no E. What's the measure of the major arc going to be in that situation?
Got 165, subtract 360.
Yeah, 360 subtract 165? Yeah. So got a complete circle, take away that, now you have the measure of the other arc there. Let's see, what else do I want to say? Let's talk angles. I don't have the toys I like here. Better things to draw on the other end of the building. That's not very good. Let's just draw a real simple acute angle. So what are two ways that we could name the angle? Just like this? I'm gonna put that thing in front of it. Not less than, but an angle symbol. Angle HIJ. Is there a second way, since this angle is just floating there all alone? JIH. You go the other direction. Or because there's not another angle associated with this, we could call it angle HJ. You could do that. Okay. If we went to the inside of this angle, on this is called the convex side. This is called the interior, or the interior of the angle. And then if we went out here on the, wait a second, that's wrong. That's not convex, is it? That's concave, excuse me. If we were on the concave side, then it would be the interior. If we were on the convex, and then it's the exterior of the angle. So the interior versus the exterior. Hi.
I've never seen things like that angle HJ thing.
You haven't?
No, I thought it was like angle I, because that's the only angle there.
She's right. This happens a lot. Not that she's right, that I'm wrong. Or not that I'm wrong, she's right. No, that's right. Angle I, thank you. But rarely in this class are we going to say things like that, because we're usually talking about more than one angle together. So the first way is how we're going to be naming angles much more often. Okay. So let's see. Let me plug in. So, be happy you're here now and not 3 years ago. 3 years ago, I made the students write everything down. That's brutal. But, you guys have those stapled together lists of postulates and theorems. You've got the angle measure postulate. I just want you to be aware of them and know what they are. You've got pictures here. The first one's the unique measure assumption. Every angle has a unique measure between 0 and 180. Yeah. Unique just means one of a kind. So if I draw an angle, there's only one measure to that angle. That's all that's saying. Now, like if that's really 165, it's not 163 and 165. It's only one angle. So it's kind of like, of course, it's very obvious. But it's something that we are going to assume. Given any ray VB in a real number, which is R, and R is in between 0 and 180. So we're saying R is a real number, which is this measure of an angle. There's a unique angle, BVA. So if you have VB, there's VB, I'm sorry, BVA on each side of this, and the measure of that angle is equal to R. So that's how they draw it here. So this is the angle R. It's on one side of VB or the other. So straight edge assumption is that if ray VA and ray VB are opposite, so that means that they're, this was a test question, right? They're opposite, the angle that's formed between those two is 180 degrees. So here they've got VB and then VA. Being that they're opposite, they lie on the same line, and they have a common endpoint. That's going to be 180 degrees, straight angle. And the zero angle assumption of VA and VB are the same. So here's VA, and then on the same ray lies B, so you have VB. Those rays are really the same ray, they're just named differently. They have a common endpoint. Then the measure is going to be zero. So that's a zero angle assumption. Those are all kind of like obvious things. But we still have to say them. Because once we say them, then we can use obvious statements to create more complex statements. And then here's some definitions. Now you guys don't have definitions on that sheet. And I know in past years, students have found it to be an advantage to have some of the definitions that were not real obvious to them written down on those sheets. So if you want to fit them in, you may do so. Maybe on that back page or something in an organized way. So zero angles are a measure of zero. Acute, you guys know that, they're between 0 and 90. They don't include 90 because 90 is going to be a right angle, that's here. Obtuse are more than 90 but less than 180. They're less than 180 because 180 is a straight angle. And straight angles are 180. So those are just all the names that go from 0 to 180. You've seen them before, it's up to you as to whether you want to write them down or not. Certainly you'll have to use them. And you can take time to finish that up too. I'll get through this quickly with you and then let you guys get working so you can continue to write things down as you need to. Okay, assumptions from drawings. You know, maybe you remember me saying in the past, you can't assume from a drawing that it is what it looks to be. So, you know, if I went and I drew something like this here, and you said, oh, that looks like a 90-degree angle. Well, we can't assume that it's a 90-degree angle unless there's something to say that it's 90. Just because it looks like it doesn't mean that it actually is. But there are certain things that we can assume from drawings. And here's what they are. Colinearity and betweenness of points drawn on the same line. So if I was to draw what we say is a line like this, and I put points K and L and M, and I put them on there and they look like they're right on the line, we can say that they're collinear. And I could, because I've got the K up here and the M down here, we can also say L is between those two. So that can be assumed. But if we have 3 or more points, so if I take 3 points like this, from X, Y, Z, we can't assume that they're on the same line unless we've got that line drawn in there. Even though they look like they're on the same line, we don't assume that they are, which kind of makes sense. And intersections of lines at a given point. So what that means is this. If I draw 2 lines like this and I say that that's point B, it sure looks like the intersection. So it must be the intersection. We can assume it is. But we can't assume that because I drew 2 lines like this, and they look, we'll say, oh, they sure look parallel. We can't assume they are unless we do something to them that states that they're parallel. So if I did something like this, I'm just drawing it again up above because some of you guys are cleaning your heads. So if I draw those and you say, oh, they sure look parallel. Well, they're not unless we mark them as such. Do you remember how to mark them so that they are said to be parallel? Anyone remember this? Kind of. Like if we were to draw a triangle and we did something like that, we'd be saying that those two sides are the same. But we do it with the arrows. So if we have double arrowheads or triple arrowheads or something like that, then we're saying that they're parallel to one another. Points in the interior of an angle, on an angle, or in the exterior of an angle. So if we have this drawing here of this angle, if I put a point here, we're going to say, well, that's on the interior. That's point A. And I put point B over here, we can say, well, that's exterior. If I had something like this and just drawn on, on the figure, that's point C, we say, well, point C is on the angle. That can be assumed. But not the exact measure of that thing. I can't say, well, that's 90 because it looks like it's 90. Only if it's marked in one way or another can we say that it is. So, with this here, can we assume that T is on N? So lowercase n is naming a line. T, because it's uppercase, is a point. Can we assume from that drawing that T is on line N? Yeah. Can we assume that the measure of angle JIK, so that's JIK, is more than the measure of KIE? Can that assumption be made? Why not?
Because just doesn't look like it.
But doesn't look like it isn't enough. I mean, that looked like a right angle until I put a box in there. What do the angles need to have?
Measure?
The measure, yes. They need to have the measure marked in some way. So if this said something like 60 degrees, then we could say that that's more than this, if we knew that this was perpendicular. So there needs to be a lot of information on there for it to be absolutely so. How about line M is parallel to line N? Can we assume they're parallel? No. You'd have to have lots of other information there. You need those double arrows, or maybe something to do with the angles, which we're going to be working with soon. How about that the measure of angle JIT is 90? No, can't assume it. Nothing there to tell us that it is that exact measure. How about that T is in between A and E? Yeah, we can assume that because they're all on the line and they're oriented as such. How about JK and L are collinear? J, K, and L. Looks like a straight line, right? But because there's not a line drawn there, we don't make that assumption. And AI and E are collinear. Does that work?
Yeah.
Yeah. All right. 117, 1 to 17.